Here's Chapter 2 review. Question number 19. You want to create a box to hold a metal wall sculpture. The cardboard has dimensions 50 inches by 42 inches. How deep should the box be to maximize the volume? So imagine that as kind of like the example we did with a piece of paper. If you take this piece of paper and you try to fold it different heights, what would be the maximum volume in there? So you have to find out what would be the maximum height to get that maximum volume. So here is the picture, not the prettiest looking picture. And it's all in X variables. So we have the X, which is the changing of the heights, and then we have to remove 2 X's on each side to give you the heights of that metal box. So what the dimension we're going to focus with on the width side is 42 minus 2x, that's your W or L. Then this is your H, and then this is your length. So then to find the volume of a box, volume in a box is length times width times height. So you don't need to draw this picture, but this is what it would be if you were to take it. Those are the 3 dimensions we're going to focus on. And I'll give you some time to, okay. You don't need to write these down. That's just identifying the 3 different sides. The length of 50 minus 2x, the width, which is 42 minus 2x, and then the height. So we're going to use this function right here. To find the volume of a box, we multiply the length, the width, and the height together. So you get 50 minus 2x, 42 minus 2x, and then x. And if you were to FOIL that all out, distribute it all out, you get a cubic function, so like a shape of a snake. And it asks you to find the maximum. So you would use your tools to graph it to find that maximum point. So one thing you might want to do is just find the zeros of the function. So it's already in factored form, so you could leave it in factored form. And you get 3 zeros. You get an x-intercept at 25, an x-intercept of 21, and then an x-intercept of 0. Okay. Then, this is a pretty big picture. Remember the y-axis represents the volume of the box, that's your f of x, your v, and then the x represents the height of the box. So you would go out and graph the snake. So here are your 3 x-intercepts, and the snake will come back up. You want to find out what's that hill. It's kind of like, come on, skateboard. Back up. Kind of like the maximum or the vertex of a quadratic. You want to find the hill, but you don't have that opposite of b over 2a. So unfortunately, you just have to try some values, you know, maybe halfway in between, and evaluate the function. In this case, if you evaluate f of 8, so we did the problem as like make a chart and just start plugging in some values to find out what would be the maximum there. So I tried, let's say 8 and 9, and if you start plugging in some smaller numbers, this is the smallest, smaller, and then starts to get smaller again. This one, to save us some time, it has the highest f of x. So f of 8 was 7,072 as its highest volume. And this will be on ClassJump too, so you can look at this too. I'm going to convert it to a PDF after 4th hour today, so you can look and check your answers. The next question was, how how do you find the possible rational zeros using the rational zero test? What question was that, 10? Okay.
So it would be.
There's a lot of them. You would, to use the rational zero test, you take the factors of your constant over your factors of your leading coefficient. So factors of C over the factors of A. And this is your C. This is your A. So you'd say, what are all the factors of 18? What are all the factors of 24? Say, what divides into 18? So 18. What else? 9. 2. So you're going descending. 6, 3, 2, 1. All of those numbers can be divided by all the factors in that denominator. So what are some factors of 24? 12, 8, 6, 4, 3, 2, 1. If it gets to be this long on a test, that's fine if you leave it in that form, if you have a huge group of it. Because what you have to do is then you have to take 18 and divide it by 1, and then 18 and divide it by 3, and then 18 and divide it by 4, and continue through the whole entire denominator, which is a lot of work, and then do the same thing with 9. Take 9 and divide it by 1, and 9 and divide it by 2, and 9 and divide it by 3. A lot. There's lots of them. So the rational zero test doesn't help us a lot. And then skip B and C. I didn't teach that piece. That works with Descartes' rule of signs. What number? 2. Okay, question 2 says, find the quadratic equation that has the minimum point. So what's the red referred to when it's talking about the minimum? This is your vertex. And then another point on the graph, so another point is at 1/8. So that's your x and your y. This is your h and your k. So the general equation for a quadratic, if I leave it in vertex form, looks like this. And now what we did is we took the h and the k and the x and the y, and we solved it for what variable? 8. Yep. So my y value, my point, was 8. My a is my unknown. My x value is 1 from my point. And I have to be very careful with this. Always opposite. Yep, so it's going to be a plus 4 squared, and then the same for k. And then what we do is we solve that equation for a. So we'll reduce down that parentheses. So 1 plus 4 is 5 squared. And then we will add 5. And then we can square that 5 squared to 25. We get 13 when we add 8 and 5 together. And then divide by 25. Then we will just rewrite the equation with a, h, and k. So there is the quadratic equation in vertex form. And you don't have to convert it to standard form by forming it all out and do all that. Doesn't need to be done. done.
And that's the final.
That's the final answer. Okay. What other questions do you have for me?